Welcome to the third day session of circuit simulation and PCB designing workshop. So myself Niraj B Kapase. I have done my masters from University of Surrey in the field of mobile and satellite communication. So before starting with the third day, we'll revise what we have learned in last 2 days. So we started with basic simulation software tools. What are the different software tools and all? Then we have learned about different analog circuit designs. We have learned about different digital circuit design, sequential circuit design and all. Okay, so we have interfaced many of the circuits with many of the tools as well. So now on the third day, we start with some graph based simulation. So how we can start with a graph simulation on the protease. Okay, so we'll start with that. Okay, I will open a protease now. So I will open a simulation wizard. So first we'll see a DC graph analysis. So for that basic digital circuitry we'll take an AND gate. We'll observe the AND gate logic. Okay, so here it is, simple AND gate. I keep the AND gate here. Now we need to generate two clock signals. So either we can generate the clock signal from here. So we have D clock available. So I will attach one D clock to one input, another D clock to the another input. So I'm going to attach one D clock to input A. I'm going to attach another D clock to the input B. Now we observe the output by using a logic state. So I will type logic state. Okay, logic probe is required. So we'll choose a logic probe. Okay, and keep the probe at the output side and connect the probe. All right, now the thing is we need to draw the graph for this. So I will give the names for this. So this is my net A. So this is my input A. So I will give a name for that is A. We'll give name for this as a B. Okay, then this is Y. All right, so I have given the names for this. Now what I will do is I will add the voltage probes for A, B and Y. So I will put the voltage probe at A. So name is A. I will put another voltage probe at B, and I will put third voltage probe at Y. So I'm going to measure the voltages. Okay, done with this. Now I'm going to change the frequency of another thing. One is 1 Hertz and another is suppose 5 Hertz. Okay, so we have changed that. Now go to here graph mode. Here it is, the graph mode is available. Just click on that graph mode. Here it is a digital graph, so select digital here. So we can do analog graph, digital graph, mix, frequency, transfer, noise, distortion, Fourier, audio. So many graphs are available. So currently we are using a digital graph. So select a digital graph. So select it and draw a graph pattern. So click there and draw one square. How much big graph you need? So already it's drawn. Now you need to add the traces on this. So how to add traces? Right click on that. So here it is, add trace available. So click on add trace. So first give the name. My trace is A, my input is A. So I'm going to trace input A. So I will choose the A, the probe A. Okay, now again I will add traces. My input is B, so I will type a B, then select the input B. Okay, so B is there. These are the two inputs. Now again I will trace add, and then Y is the output. So select Y and select here Y. Click OK after this. So all three things are added, A, B and Y. So the graph is available now. Now you can run and test. Once you run this particular circuit, so 0 1 0 1 0 1, because of high low, the status is going to change. Okay, so still not, graph is not been shown. So click on the graph and put a space bar so that the graph will observe. Okay, now you can observe that whenever the A input is low and B input is high low transition, then also the Y is low. But in case of A is high and Y is high, at that time we'll get output as high. So you can observe the graph. Now there are different properties of the graph as well. So you can simulate the graph, you can view the simulation log as well. So if you view the simulation log, you will get all the time analysis of the simulation log. Again, if you click on that, you can maximize the window. You can maximize this full window. Here it is digital analysis of the graph. So you can have here low signal, here it is high signal and all. Okay, again, once you close this, again graph will come down. You can export the data in different formats as well, or you can edit the graph. If you want to export the data, that data will be saved in a data file. You can save that particular data file and you use it. Okay, so these are the different options available with the graph. You can only simulate a graph by using a space. Just I have informed you, this space is a shortcut for doing simulation a graph. Okay, so this is about the graph simulation. Okay, so you can give a name of the graph as well. So here it is AND gate analysis, so you can rename it as AND gate analysis. So like this we can do, and the name is available here, no problem. Okay, it's done. Now you can stop simulating this and then save this particular thing. Alright, okay, next we'll see analog or DC sweep analysis with a diode. Okay, open Proteus again. We require a diode, so I will type 1N4007 as a standard diode, standard silicon diode. I will choose this standard silicon diode as it is, so I will put a DC sweep analysis for that. I will keep a diode here. Okay, then we require a DC voltage source, so I will, from the generator mode, I will take a DC voltage source. So how we can do a DC analysis? We'll change on it. We are going to change the voltage with respect to time, and then we are going to measure the current. Okay, current versus voltage. Okay, so we require a ground, so select this, ground it, go to terminal mode, select a ground, put a ground, connect the ground. Okay, done with this. Now you want to change the properties of this particular DC voltage source. Just double click on that. So here it is a D of A and 0 volts, so don't keep this, go to manual edits here. So instead of this value is equals to 0, instead of this value is equals to 0, make it value is equals to V. Okay, click OK after this. Now we need to take a current probe, so go to probe, then select a current and then attach a current probe here. Okay, current probe is attached. Now current probe name is D1 of A. Go to graph mode, select a graph mode. From this we need to analyze DC sweep analysis, so select DC sweep and draw one particular graph. So I have drawn a graph. Now you can have, go to this, go to add trusses. So we need to add D1 of A. Okay, expansion is P1. Click OK after this. D1 of A is added. Alright, sweep analysis. Now go to this, edit properties of the graph. Now here sweep variable, instead of sweep variable, what we have done is V. So we need to keep a sweep variable as a V. Start value is 0, end value is, suppose I need to make it till 5 volt. So go to that. Nominal value we can find it me. Step size, so 100 steps within this will take. Okay, 100 readings within 0 to 5 it's going to take. Okay, click OK after this. Okay, now you can run this particular thing. Once you run, it's animating, you will get animation here. Stop this again and then just select a graph and put a space mark. Okay, you can observe that the graph is going to change. Currently it's not visible. Why? Because its size is 5 volt is too huge, because at the 0.7 only it will rise. So what you can do is you can change, instead of 5 volt, instead of that we can do it for 2 volt. Okay, and again run it. Stop this again, make a space bar. You can observe this. Okay, this is current versus voltage graph you are getting. Okay, current is going to increase. Alright. Okay, next is AC sweep analysis we'll do. For that we require a filter circuitry. We require one resistor, so I will type resistor. So select this resistor, and we require one capacitor. So type CAP as a capacitor. Okay, only 2 components are required, so we have already selected those components. So I will keep a resistor here, okay, and then the capacitor I need to keep. So I'll rotate the capacitor. I will keep the capacitor like this, and I need to connect with a ground. So I'll choose a ground, connect this with a ground like this, like this. Okay. Now in case of a source, we need to choose a sign. So choose a sign, connect the source here. All right, the sign is been connected and the source has been connected towards the sign. So okay, so double click on this property, 1 amplitude and frequency is 1 hertz. Keep as it is, doesn't matter. Double click on the resistance and change the property to 10 into x. 10 into x. Okay, 10 into x. Sorry, so I'll put into mark 10 into x. Okay, x we are going to assign. Click OK after this. 10 into x is my property for that. Take a voltage probe. We are going to measure the voltage. So from here, the probes, I'm going to take a voltage probe and I will take measure the output voltage as C1 of 2. Okay, so instead of that, I will make this as V. Okay, click OK after this. Alright, so the circuit has been completed. Now what the thing we can do is go to graph mode and select AC sweep graph, AC sweep analysis, and draw the AC sweep square. Okay, AC sweep analysis is there. Then right click, add a trace. So we need to add a trace of V. Okay, voltage. Click OK after this. Now go to this edit properties. So reference will keep of R1. R1 is your reference, and then we need to keep starting frequency is 10 up to 1 mega. Sweep variable is capital X that we have already assigned, start value and end value, and the decades we will keep as it is. Click OK after this. Alright, done with the steps. Now you can run this particular thing and then again check the output. You will observe different waveforms here. Okay, so these things are like low pass filter, so we'll have lower frequencies will be passed and higher frequencies are blocked. So you can maximize this by just double clicking on that show window, so you can observe the different window size. Okay, so this is AC sweep analysis. So like this we can do a sweep analysis of this as well. Okay, so it's very suitable software for analysis of different circuitry as well. So I'm going to save this particular circuit, the circuits. So it's a circuit 19. All right. Okay. Now we'll move towards some microcontroller based schematics. How we can simulate the microcontroller based circuitry. So before starting with the simulation, I'm going to explain you the code. So we'll open. So you can use any of the coding language for writing the code of microcontroller based simulations. So here it is. I wrote assembly level programming, and in this assembly level programming, what we have done is we have used 89C51. So you can look at the target. I have done the programming for 8089C51. Okay, and I have changed the frequency as 11.0592. Okay, so here is the coding org000h. I jump to main, so it will come to main. First of all, I make that port 2 as an output port. Then I'm sending 55U and then the call delay. Again sending AA call delay, so that alternate LEDs will blink. So it's a flashing. Okay, again call delay. In the delay routine, we have written a delay routine like this. So it will loop this. So one count is FF, another counter is again FF. So it is going to run this particular time for 255 multiplied by 255 microseconds times. Okay, so I'm going to compile this first. So before compiling, we need to create an hex file. So for creating an hex file, click on output and then select this create a hex file. Then click OK. Okay, and then compile it. So once you compile, the LED blink has been created. Now how you can simulate this? So for simulation, just minimize this as well. Then open your simulation tool, that is Proteus. Open your Proteus simulation tool. Go to your schematic. drawing option. Okay, here it is a schematic drawing option. Now click on a parts. Now select 8089C51. Here it is, microcontroller available. Now I'm going to show you how you can connect a bus with the LEDs. So I'm going to select this. All right. Now we can take different LEDs. So I will require LED, type LED. So here are different color LED available. So I will take a blue, click OK. I will connect it here somewhere. Okay, some 2, 3 and 4 blue LEDs. Okay, now I'm going to take another LED, type LED. Then I'm going to take a red LED. So I'll take a red LED. I will put the red LED in between. Again, I will take another LED as suppose green LED. Click OK. I'll put green LED here. You can take LED. There is one more LED is available, yellow color. Click OK. I'll keep LED here. Okay. So all LEDs are connected. Now I'm going to connect first all the LEDs ground, cathode to a ground. So we'll connect the ground first. Okay, ground is available in terminal mode. So go to terminal mode, select a ground, connect that with the ground. Done. Now I can connect individually like this as well, like connecting this to this, connecting this to this and so on. But I'll show you how you can use a bus so that messing of wires will remove. So here it is a bus mode. So select this bus mode and draw one bus. So from here I'm drawing one bus. Okay, bus has been done. Now you can connect the wires from this particular line towards this bus. 1, 2, 3, 4, sorry, 5. This is 2.5, 2.6, 2.7. So only a single line will go there. Now again, this I'm going to connect it here again. 2, 3, 4, 5, 6, 7. Okay, done with the connections now. Now this bus is internally carries. So as many lines you can use particular this bus. Currently I am using 8 lines, but you can have as many number of lines. So again go to a selection mode, and here there is one option. Select this particular bus. Okay. And here it is assignment, property assignment tool is there. So here it is a tool. So click on that property assignment tool, property value. Okay. Value, instead of value you can put P1 P2 dot hash. Hash is incremental value. Here it is the current count value is designated with a hash symbol. So you can put a hash symbol. Property is equals to P2 dot hash. Okay. So click OK after this, and then I can give this particular thing as value. Sorry. We have connected this particular wires with the bus. Now you can go to a property assignment tool. Here it is available. Just click on their property assignment tool, and then these are the nets I'm going to connect. So net is equals to P2 point hash. Hash is the incremental value. The current value is 0. So you can have count 0 to increment by 1. So 0, 1, 2, 3 it will going to increment. So I will click OK after this, and then just go to a particular net, first net. Click there. So 2.0, 2.1, 2.2, 2.3, 2.4, 5, 6, 7. So all 7 nets are connected. These same nets are replicated over here. So again go to property assignment tool, again select property 2 point hash, click OK after this. So it will restart from 0. So this is 2.0, it's 2.1, 2.2, this is 2.3, 2.4, 5, 2.6. One more is required, so I'm going to take one more LED here, new, and then I'm going to connect it here. I'm going to connect it to the bus, and then again go to same 2.6 is there, so we require 2.7. So click OK. Once you click OK, but this will be started with 2.0, so double click on that. Sorry, go to this, double click on this particular thing, so change it to P2.7. So it's done with this. Okay, so D0 to 7 is connected. Now go to selection mode, okay, double click on the component. Okay, so once you double click on a component, so we'll have a frequency 11.0592 because we have set there as 11.592. Go to program files and then select, go to your desktop. My code is available here at 051 led.blink. So select that particular file, click OK. So this is the hex file given for this, and then I can run. If you run this, the program will run and you will get alternate LED blinking. So you can observe this LED blinking is running. Okay, I will repeat one more time. So just double click on the IC. There is a program file available. So just browse for the program file, select your hex file, click OK, and then run. Once you run it, you will have your code is running on the Proteus. Okay, so save this particular thing. Alright, so similarly we can have LCD interfacing as well. So I will explain first the code of LCD interfacing. Okay, and then it is written in embedded C. So we'll see that. We'll open a CADE. So CADE is again an IDE, that is Integrated Development Environment. Okay, so here it is a code for writing on the LCD. Hash include reg51.h command write. Here it is one function with one argument, another function with another argument as a data write, delay, rs 3.4 I am going to connect, enable I am going to connect it at 3.5, and then these are the messages, hello world on the first line, welcome on the second line. These are the command words for writing this. Now I will write the commands. First I will send 5 commands using this for loop. Okay, next this is for line 1. Then I will send first message 1 I will write. This command is for line 2, that is the second line. Again I will send message 2 on the second line. Whenever I am writing a command, rs should be 0. Here it is done. Enable pulse, I have started with enable pulse, and whenever I am writing data, rs should be 1 and enable pulse again, and then delay is 11275. Okay, so I am going to compile it. Now I will show you how you can use a bus structure for connecting this. I will close this particular thing. I'll open. Sorry, I'll open the Proteus again. Now we'll do labeling. How we can do a labeling of the components. So instead of messing up all the things, one thing is you can use a bus, and another thing is you can label the components. So how you can label it? 889C51. Select this 889C51. Click OK. So this is your controller. Okay. Alright. Now I need to require LCD. So type 16:2. So you'll get LCD 16LM016 is alphanumeric display. Click OK after this. So here it is my LCD. Okay, so you can do like this connections, but it's mess up. So instead of that, what I can do is I can have like this labeling. Just I will create a nets over here, and I will give the names, respective names, which are going to connect automatically to the controller. I will see. This is my 2.0, 2.1, 2, 3, 4, 5, 6, 7. Okay, and 3.4 and 3.5. So we'll connect 3.4 and 3.5. Go to label. So here it is my RS. So I'll make caps lock RS. I will name it RS. This is my enable, and I will name this as D0. This is my data lines. So D1, D2, D3, D4, D5, D6, and D7. Okay, so same names I need to give it here because I have connected port D0, D1, D2, D3, D4, D5, D6, D7. Okay, you can use multiple sheets as well for writing that. So this is my RS and this is my enable. So I have given name as RS and enable. So one more thing is required, that is RW is grounded. So I will select ground and I will connect the ground to the RW. Okay, now the schematic is ready. Now we need to give a hex file. Just double click on this, change the crystal frequency as 11.0592 megahertz. Go browse this particular code, go to a desktop. So I have saved that particular LCD code. Select the LCD code, click OK after this, and just run this particular button. You can observe your code is running. So hello world is written on the first line and the welcome is written on the second line. So it's having very good interactive simulations as well. Okay, so you can run many simulations. It's having touch screens, it's having graphical displays, it's having 16:4, 16:8 displays, multiple graphics displays are available. So it's very nice simulation tool. Okay, so save this particular thing. Okay, now you can simulate some Arduino based simulation as well. So we'll see that Arduino based simulation. So I will open again a properties, select a new file, type Arduino. So once you type Arduino, there are different Arduino versions available. So starting with Arduino Mega, Mega R3, Arduino Uno R3, DIL packages, DIL6 packages, Arduino Audio is available, Glue sheets are there, Matrix, UART, then some ultrasonic sensors are also available in this. Okay, so I will select Arduino Uno R3, click OK after this. So this is here, it is a Arduino Uno R3. So what we can do is we can write a serial code and we can observe a serial data. So for that I will open a code, the circuit. So I have Arduino serial code. So Arduino serial, I will open this particular code. Okay, the code is open now. So I will hit the compilation button. So here void setup serial begin 9600 serial.println hello world. So it is going to print hello world on the first line and void loop and then the stop. Okay, so it's compiling. So till that time we'll connect the simulation hardware tool. So we'll select a virtual terminal so that it displays the virtual outputs here. So there are 4 pins again. Okay, so we'll move a little bit this side. Okay, here it is a virtual terminal. So in this RxD we need to connect it to a TXD of Arduino, and RxD we need to connect it to a TXD of this. So it's a cross connection we need to do. Okay, once it's compiled, so let's check it's compiling the sketch. Here we'll get a hex file and we need to pass that particular hex file for the Arduino. Then it's going to run whatever the Arduino code is written. Here we wrote a code for hello world to be printed on the screen. So if you want to do this repeated task, then I will write here serial dot println hello world welcome. So welcome is printed with a delay of suppose 2 seconds, so delay of 2000. So it save it again, compile it again one more time. I have to compile it, verify it. It will take some time. Now it's done compiling. We'll get a done compiling message here. Now we'll select hex file. So hex file is available in verbose. So we'll look for hex file here. Here it is. Oh, sorry. Okay, here is the hex file available. So in the verbose, I have to select the hex file. Okay, hex is available. So just copy this particular file, go to your simulation, just double click on Arduino. Here it is a program file. So select the program file and then paste your hex file code. Click OK after this, and then just run it. Once you run it, it will print the output here like this on this. Suppose if you miss some values like baud rate is changed. So suppose I am sending with 4800 and I am transmitting it 9600. You can observe garbage data here. So this is simulating. So whatever the errors and whatever the things we can do, those things are replicated here. Also there is one option that we can directly connect hardware with the proteus as well, and there is for that there is a comp pin available. So I will show you that thing. So go to components, type here comp pin. So once you type com or sorry com connectors, sorry it's in DIL, so DP9. Okay, so comp pin is available, so you can use a comp pin for connecting this with external hardware.
Okay, next we'll see how we can design in PCB. So PCB design steps. Okay, so we'll start with that. There are different steps to be followed for designing of a PCB. So steps, I will name those particular steps. First is the design. So we need to draw the schematic. We'll discuss all the points in detail. So these are the different points available for designing of PCB, like the design, the printing of the design, how we can print the design, creating a substrate, printing of inner layers, ultraviolet light, removing unwanted copper etching. Then inspection is there, laminating the layers, then pressing of the layers, drilling is the important point. Then plating is there, then solder mask application, seal screening, surface finish, and then the testing. So these are the around 15 steps are there for generating a single PCB. So we'll see step by step what are the details of each step. So first thing is design. In the design, you should design a circuit. So first you need to draw the circuit, prepare your schematic, and use any software for designing this particular schematic. So first day we have discussed many softwares regarding how we can prepare the schematic by using different softwares. Okay, so this is design. The second step is printing of the design. So how you can print your design. The special printer is used known as a plotter printer. For printing of industrial grade PCBs, they uses a plotter printer. It includes the film that shows the details of layers and the board. So it is a film actually, and it shows all the layers as well as all the like in between layers, top layer, bottom layer, and everything. When printed, there will be two ink used on the inside layers of the board. There are two inks they used: clear ink to show non-conductive areas and black ink to show the conductive copper addresses and the circuit. So there are two types of ink. Clear ink is there, so that is non-conductive area, and then the black color is there, that is for copper, conductive copper. The same colors are used for outer layers, as the meaning of them is reserved. Okay, so like this, there are different colors patterns for different layers, as well as there are different color for conductive and non-conductive layers. Okay, then next thing is creating in substrate. So how we can create in substrate? Substrate is now is when the PCB will start to form. The substrate, which is the insulating material, that is epoxy resin and glass fiber. It holds the components on the structure. So it's a plate actually, and the plate consists of epoxy layer. It is made up of epoxy layer. On one side there is full copper if you are doing one-sided PCB. If you are doing two-sided PCBs, there are two-sided coppers are there. Begin forming by passing the material through oven to be semi-cured. Like it has to pass through the oven to be pasted with the copper and all. So that thing is there. Copper is pre-bonded on the both sides of the layers and then etched away to show the design from the printed films. Okay. Next, how we can print in the inner layers. For multi-layer PCBs, the inner layers are there. So how they are going to print? The design is printed to the laminate and body of the structure. A photosensitive film made up of photoreactive chemicals that will be hardened when exposed to the ultraviolet light. The resist covers the structure. Like we have the substrate, okay, that is epoxy plate, and then we have your like image on photo resistive material. So we place it on, and then we pass it through ultraviolet light. This process helps align the blueprints and with the actual prints of the board. So we need to align all the prints with the same tail points and all. So we need to have edge marking for each and every PCB, so that we need to align all the layers, all the boards layers as well. Next thing is ultraviolet light. Once aligned, the resist and the laminate goes under the ultraviolet light to harden the photoresist. Okay, the light reveals the pathways of the copper. Like as I told, the copper is there, so the ultraviolet light will not pass through that particular copper because it's a black. Because of that, the copper will keep there, and rest of the part will be exposed to the ultraviolet light. The board is then washed with alkaline solution. Generally, alkaline solution it is used as FeCl3 as a alkaline solution, and it is passed to the photoresist material, excess of the photoresist material. Okay, removing unwanted copper. Now it is time to remove the unwanted copper that remains on the board. The chemical solution FeCl3, similar to the alkaline solution, eats away the unwanted copper, and the hardened photoresist remains intact. So whatever the tracks are there, those tracks are left remain, and rest of the part will be removed through alkaline solution, that is FeCl3 solution. Inspection. So the newly cleaned layers will be inspected for alignment. The holes drilled earlier help align the inner and outer layers. As I told, there are 4 holes at the bottom edges of the board, and those helps for the alignment of the board. The optical punch machine drills a pin through the holes to keep the layer lined up, because all the layers should be lined up to create a very good PCB. The laminating of the layer. So lamination of the layer, now you will see the board take a shape as the layers are fused together. The metal clamps holds layers together for the laminating process. The layer of a substrate goes to prepreg, followed by a copper foil layer and more prefeg resin. The prefeg, that is epoxy resin layer, goes on the alignment basin. Here it is, like prefeg is there, so inner layers are there, top layer is a copper again, bottom layer is a copper. So like this prefeg process is there for alignment of multiple layers. So this is a laminating process. Pressing the layers, mechanical press is used for pressing that particular layers. Then the PCB will go to the lamination process, which applies the heat and pressure for the layers. The epoxy melts through, and the prepeg that along with the pressure fuses the layers together. Then next point is the drilling. The holes are drilled into layers by computer guided drill to expose the substrate to the inner panels, and then any remaining copper after these steps has been removed again. So drilling is a normal process again. It is auto CNC machines will drill each particular point with a drill point. I will show you the what is drill file and all. Next is the plating. The board is now ready for the plating, and the chemical solution fuses all the layers together. Is a bonding. Then the board is then thoroughly cleaned by another series of chemicals as well. Okay. The outer layer imaging, so ultraviolet light, the same as the step number 3, outer layer imaging. Again, we need to put ultraviolet light in photoresist material, and then FeCl3 solution, etching and all. So those steps are repeated for the splitting and etching. So again, etching is important. Etching to remove the unwanted copper. The etching we are going to do in this. Solder mask application. Again, to protect your PCB from corrosion, we need to apply a solder mask. All the panels should be cleaned before applying the solder mask. The epoxy is applied on the solder mask field. The solder mask applies the green color. You typically see on the PCB there are many colors available now in the market. The unwanted solder mask is removed with ultraviolet light again, and while unwanted solder mask is baked on the board as well. Then silk screening. Silk screening is a vital step since the process it wants to print critical information on the board. Like we need to have labeling of the components, we need to have a tracks and all, we need to have company name, logo and everything. So that will be in a white color or any other color as well. So that is known as silk screening. Once applied, the PCB passes through one last coating and the curing process. The surface finish. The PCB is plated with either a solderable finish or depending on the requirements, which can be UNIST. Surface finish is there. Then next last point is the testing. So after mounting everything, after creating and everything, we need to test the PCB manually. After that, we need to test by mounting components on it, and then actually final PCB has been done. So there are different parts of the PCB. Just we have seen the process of creating in a PCB, but we need to see different parts of a PCB. First part is electronic components. So you know about electronic components. Next is pad. What do you mean by pad? What do you mean by traces, wires, top copper layer and bottom copper layer? We'll see in detail. So pads. In the PCB, the location of a component that connects. So this is known as a pad. So here it is an IC pad. So this is known as a pad. So here we can fix one IC. Here we can fix a resistor. So this is actually a assembly component. So these are all appears on the top layer. And this IC1 is written. This is known as a top silk. R1 is written, this is known as a top silk. Q1 is written, this is known as a top silk. Okay. The pads will connect the traces. So traces means there are different wires. So that is known as traces. Pads have inner diameter and the outer diameter. So pads have both the diameter, like inner diameter and outer diameter. Here you can look, this is a pad. So it's having inner diameter, it's having outer diameter, and this is a hole. Little bit is there. So again, pads are very important. Next is traces. So traces connects the part together. Like these are the pads, and then these are the traces. So this is connection of the wires. So nets are known as traces. Traces are essentially a wiring of the PCB equivalent to a wire conducting signal. Traces sometimes connect the wires. So here are different wires as well. So wires, we'll see what do you mean by wires. High current traces would be white. So the current traces will be white, and low current traces or signal traces will be narrower in the size. So that depends on how much current is flowing from that particular wire. Next thing is wires. So again, wires are very important. The pads with a plated hole connecting traces from one layer to the another layer is known as a wire. So like we have a PCB and we have a connection from top layer to the bottom layer, then there should be a wire. So connecting from top layer to a bottom layer is done by a wire. Sometimes leads can be used as a wires. Sometimes the end leads can be used as wires as well. So here there are different wires in the PCB. So many wires are there. So this is a big complex PCB. So we have to see the wires here. So there are different types of wires available. So through hole plated wire. Through hole plated means from top till the bottom layer. So it is a through hole plated wire. Not plated wire means there is no connection, only a drill point is there. Just here it is plated wire. Plated means it's here it is a copper is available. Okay. So blind wire. So wire comes from the top layer, but it will not reach till the bottom layer. So it ends in between. So this is a blind wire. Again, this is again a blind wire. It starts with in between layer and ends at the here. Buried via, so it will not start at top layer, it will not start at the bottom layer, it will start in between layers like this. So in between layers the connection is there, so that is known as an buried via. Tinted copper, tinted cap means we need to put one cap on the top, so this is tinted cap and this is a through hole plated. So these two are same, through hole plated and tinted cap are same. If we cap the through hole plated, then it is known as a tinted cap. Then plugged, we need to put some copper in between that, so this is a plugged wire. So there are different types of wires, like so mainly blind and buried wires are used, and copper and plated and non-plated wires. Okay, so this is about wires. Top and bottom copper layer. So most of the components resides on the top layer, fewer traces on the top layer. So most of the components on the top layer and fewer traces on the top layer, lesser components on the bottom layer, as we know already. Most of the soldering has been done on the bottom layer. Then more number of traces are available from on the bottom layer. Okay. Then there are some jumpers available. So many signal wires exist on the small space that may overlap, so we need to equip a jumper, so we can fix a jumpers over there. Running traces on the different layers is the option. Multi-layer PCBs are often expensive, that's why the solution for that is use a jumper wires. Then next we need to apply a solder mask. The protect copper traces from outer layers from the corrosion, we need to apply a solder mask. Here is without applying a solder mask, just I have designed this 12 volt plus minus 12 volt power supply. I will show you the design of this as well. So we are going to design this as well. So this is a PCB, and after applying the solder marks, actually how it looks like this. It looks like this. Okay. So it's a 2-layer PCB. Then top screening. As I told to you, the naming of this things is known as top screening. So here it is R1, IC1. So this is top screening. So it's a color actually, which gives you readable information about component, part, numbers and the placement, helpful in assembling, testing and servicing of the circuit board. Okay, so we'll see a demonstration of the PCB now. Okay, we'll start with basic circuit diagram, like voltage divider circuit diagram. So we already seen, I will repeat the resistor. So if you choose a resistor, you can look at this. If you choose a resistor here, the symbol is a resistor. Resistor is there. So we have different options like this. So we have a PCB preview. So we can choose a different options for the preview. So a resistor 40 is this is a standard resistor. If you are using a quarter watt resistor or 1 watt resistor, so we need to change the dimensions. So we need to look for the dimensions. So these are the SMD components. And this is actually a DIL package, like a regular package. So I need to choose this particular package. If you miss this particular package, your PCB will be wrong. So you need to select this particular package and then click OK after this. Then we require a battery. So type battery. Again select battery, DC voltage source, and the battery is not a PCB component, so it will not available a PCB preview. So click OK after this as well. Then that's it. We need to connect the circuit. Here we go. So one will take only okay. So I have connected this like this. So I have used 4 resistors and then battery B1 and then this. So I'm going to connect with the wires, these things. Okay, connected, then done with this, done with this, done with this. Okay, so just for simplicity, I have done this particular circuit. Now you can change the values of this, or you can change the names of this. You can do this already. We have explained this, but the battery is not a PCB component. So instead of a battery, I can use a connector, so that I have 2 DIL points on a PCB and I can connect the battery over there. So for that purpose, I have to type the component name as connector dash SIL. So SIL stands for single in line. So if we go to connector, I will select subcategory as SIL. So we'll have SIL connector. So SIL2, battery is a 2-terminal device, so we can select SIL2. So the package is available. So regular package is available 1 and 2. Okay, so I will keep OK after this, and I will attach the SIL2 package here. So one terminal will go towards positive side and one towards the negative side. So these are the points for the battery. Now I can right click on that, go to edit properties. I can exclude this from the simulation. So I can click on exclude from the simulation, but I require this for the PCB layout. So I will keep this as it is, exclude from only a simulation. Click OK after this. Now I don't want this battery to be present on the PCB layout, so I will exclude that from the PCB layout. So this thing is very important. So like including which components you require for the PCB, which components you require for the simulation, that decision is very important. So exclude it from PCB layout, click OK after this. Now done with this schematic. So you can look at the schematic, very simple schematic I have drawn. So I'm going to save this particular schematic. Okay, I will go to a desktop. So here it is. I can save it with circuit 22. Okay, I have saved this particular thing. Now the next thing is we need to go for a PCB layouting. So here it is option known as a PCB layout. Okay, so you have to save this particular thing and then click on PCB layout. Once you click on a PCB layout, another perspective window will open. This is PCB layout window. Whatever the components you have already included in the schematic, those are already in this component list, already captured in this particular component list. So I'm going to explain what are the things available on this particular tool. This is known as an arrays tool. So here it is again a selection mode, component mode, packaging mode, track mode, vias mode. As we have explained, via, if you want to create a via, then zone mode is there, then ratness mode, then we have connectivity highlighter, then there are different points, then we can have naming and everything. So here are different layers available, up to 14 layer PCB we can do, like top layer, bottom layer, top silk, bottom silk, top edges, bottom edges, top plate, bottom plate, then internal layers, skip out layer, occupancy, board edge and all. So these layers are there in this as well. Okay, also we have here different tools available, like we can have save, we can have export graphics tools and everything, test points are there. Then we have netlist creator, CAD file maker, then we have tidy, we can replace the components, align the components, you can take a new component, we can have meters, then redraw, drawing facilities are available here, toolbar is there, libraries are there, toolboxes, auto router, auto placer, gate sweep, gate swap, then power plane, automatic annotator. So these things are there. Design rule manager, we can configure a design rule manager as well. So what are the rules and all, so we'll see that step by step. Okay, so just if you look at the components, all the components are available with their packages. Okay, so very first thing, again this blue line shows you where your PCB will be. Okay, just maximize the thing inside this blue line. Okay, very first thing, we need to draw one board edge. Board edge means how much is size of your PCB. So for drawing the board edge, select the square. Here 2D graphics mode, very first thing, 2D graphics mode. Go to the board edge. So yellow color is observed for the board edge. Draw one square. Okay, you will get the size at the bottom hand side. Okay, done with this board edge. Now we need to place the components. How you can place the components? Go to this, select the wire jumper. So first component has been placed, so rotate it. You can look this, 2 is connected there, R1. Whatever components you are placing, look at this. If I place the components, that component will be removed from the list. R2, so R2 is at the bottom side. Okay, then R3, the next component. Then R4. Okay, done with the component placement. Now you can finalize your board size. Board size is too big, I have drawn, so I can reduce the board size. So this is my board size. Alright, So done with the board placement. Now we can draw the wires by two methods. One is auto routing and second is manual routing. So with this circuit we will see a manual routing. So how we can do a manual routing? Go to a default track mode. So click on the track mode. Here it is the default track mode. So we used to right click on the track, default track, go to edit and change the width of that. So width are measured in the threads. So generally if you are creating a PCB at your home, so thread size must be 25 to 35. So in between 25 to 35. So I will keep 30 th. Okay. So because if you draw very small thread, then it's very difficult to etching process and all. So 25 thread will be fine. Now after selecting that, go to copper layer. So I'm going to draw this copper on the bottom layer. So I will select the bottom copper. Then okay. So click on the first point. So you can observe it will show me the connection. So my connection is this. Rest of the connection it will hide, like make it small. Okay. So if you press the enter, automatically it will connect there. Okay. The Proteus is having a very good facility that once you press the enter, it get automatically created, or you need to draw like this. Okay, once it's connected, the net name has been given and the connection steps has been completed. So first thing is done. Alright, so second thing, just click there, press enter, let's get connected automatically. Okay, second point is connected. Third point, again it's highlighted. You can draw manually or we can have automatic connection. Okay, for automatic connection, just click there and press enter. So this thing, and last point is this to this. Okay. All right. So you can look, the each net is having name. So this is 0001. This 01. This net is having 02 name. This is having 03. This is having 000. See, this is the ground line. So each net is being named. Also, you can put the name if you require the name on the bottom copper. You can put the bottom copper name voltage divider PCB. Voltage divider PCB. So you can look this thing. So this is in a mirror layer. Why? Because it's written on the bottom side. And if you want to write the name on the top layer, so we need to select the top silk, select the A, select top silk, and then write the name. Voltage divider PCB, click OK. So this is in the same color. Okay, so you can overlap because these are on top layer and the bottom layer, so that will be fine, no problem. Okay, so this we have done with the PCB. Now we can see, you can check here, no errors, no DRC errors as well. So we will get these two options ticked. There are no errors in the PCB. Now we can have a 3D visualization of this. Okay, here it is the option 3D visualizer. Just click on the 3D visualizer. We'll observe the 3D visualizer. Here it is a jumper. Here are 4 resistors, R1, R2, R3 and R4. We can rotate by clicking like this. So here are the tracks available. So whatever the connections we have done, so these tracks are available. Voltage divider PCB. So this I have written in the copper, so that's why it's there. And the top side also I have written in the top sill. Okay, you can remove the components like this. Here it is. Sorry. Putting a box, removing the components and taste, putting components in a taste. Then we can have flip the board like this. So you can flip the board as well. So that there are different options available here. You can zoom in, zoom out. You can find light, enter navigation and all. So 3D visualization is also possible in this. Okay. Then how we can get an output of this? So we can have here bill of material and everything. So if you click on a bill of material, so whatever the components I have used, so those components will be listed here. Look at this. So I have used battery B1 12 volt, J1, then with the connector, and 4 resistors. Quantity of this is 4 resistors. I have not kept the cost, that's why its cost is 0. So you can prepare a cost window here, and we can give the values there directly. Bill of material, what is the value of resistor, what is the value of capacitor, what is the value of and all. So automatically the bill of resistor will be generated, okay, with the date and time, and everything will be generated with the bill of material. Now we can have another thing is we can have a design explorer. So we can have a design thing. What we have done is which package we have used, where we have excluded, what we have included and all. So those things are roughly available. So we can have different sheets available and all. So that thing is possible in this as well. Okay, so this is a Gerber view. So if you click on a Gerber view, so which gives you a Gerber view. Okay, so how to export this now? So there are two options. I can go to a layout, then go to output, click on export, export a bitmap. So if you export a bitmap, so just like by at home, if you want to create an PCB, just select the layer, that is bottom layer. Rest of the layers you need to remove. Okay, bottom layer and board edge is required, so I will select that only. Then I require 100 dpi mono, that is black and white in color. Then we require a mirror, and then I can give the location output to the file. Okay, circuits on circuits 22, then click OK. Once I click there, so my output is available in circuit 22. I will show you the circuit 22 file, circuits, circuit 22 PMP. So this is actually my PCB in a BMP. I can open with any of the viewer. Actually this is a PCB. I can take a print of this, and I can do the PCB at home as well. Okay, so you can look at this, how it looks like. One more thing, why I have make this as a triangle, because every time I can draw like this as well. So I will show you the thing. Select this, I will draw in 90° as well. But the thing is, the electron gets accumulated, and because of this it's generated a heat. Because of this copper may detach from that epoxy layer, so it's a very life of the PCB will reduce. So that's why every time don't do 90° at the edges. So we can have tilt sign at the edges, and then we need to connect it. So every time avoid 90° connections at the edges. So this is the rule while designing any of the PCB. Alright, so next thing, if you want to generate the Gerber for like automated CNC machine, so I select generate a Exelon Gerber. So we can run reproduction check now. Yes, so it is going to check everything. Okay, different layers, imaging, copper, taste and all. So those tastes have been generated. So it shows you errors and warnings and all the things, what are the things we have done, and then what is the fails report and all. So after that, it's closed this. Now you can select different files and layers. Okay, done with this. So I can create a single zip file of this. So I'll select all the layers and everything. Okay, then I will put this after this. Okay, so I have done with this. So you can view Gerber viewer as well. So Gerber viewer will view all the things. So these are the layers, these are the things and everything. So we can observe that on a Gerber viewer. Just minimize this. Now we can see that zip file. So this is a CAD/CAM zip file. So it's automated CNC machines. We can use this particular file for generating an PCB. So I will explore this particular file, what is there inside this. So I will extract it here. So if I click on circuit 22, so we can have different points, that is Gerber points are there. Okay, GBR files are there. So we can open these GBR files from TXT. So you can open it through a TXT as well. So this is a bottom copper, this is top copper, netlist and everything is available there. Okay, so you can have readme TXT. So everything is mentioned there. So what is circle, what is the beat and square and everything, top copper, top resist, end of the file. So this is a readable file by the CNC machine. Okay, all right. So this is about the simple PCB. Now we'll see IC based PCB for the second experiment. Okay, we'll save this particular project. Okay, for IC based PCB again we'll take 555 as and we'll see auto routing of the IC based PCB, how we can do auto routing and all. Okay, so we'll draw 555 base flasher circuitry. So I will take a 555. So if I take a 555, you can look, this is a preview of the 555, and here it is a model. So you can select the DIL, that is dual inline model. So I'll select that, I'll draw this. Okay, then I'm going to take LEDs. So LED, if I take LED, so LED is a PCB component, but PCB preview is not available. So how we can assign the PCB preview for this? So I will take a red LED as it is. Okay, then we require a resistor and a capacitor. So I will type resistor. The PCB preview is there, but I need to change that PCB preview as RES40. So I have changed it here. Click OK after this. Then we require a capacitor. I will type CAP. Again, we need to select this capacitor. We can keep as it is, capacitor 20. Okay, so these are the things we require already. Okay, we require one connector as well for power supply. So I can type connector dash SIL 02. The component names you must be remembered while designing a PCB, because this is important. Okay, so select this as well. All right, done with the component and all. So we'll do connections. Two and 6 are shorted. Okay, then I'm going to connect the connector SIL. Rotate this. One is VCC, so I'm going to connect it like this. Another is ground, so I'm going to connect it to this. 2 and 6 are shorted, and then the ground is here. Okay, ground is connected. Now I need to put the LEDs. Rotate the LEDs. 1 and 2. I will keep only 2 LEDs. So I'm going to connect with 1.2 the VCC. The second is the output, so I'm going to connect it like this. So PCB preview is not available for the LED. So how to assign it, we'll see. Okay, so then we require to connect the resistors. We'll rotate it. One terminal is here, another terminal is to pin number 7. Okay, then the resistor is there. Okay, then one capacitor, and then the ground. I'm going to connect like this, and then second terminal is grounded, so I will connect like this and like this. Okay, so change the values of the resistances. So double click on that. So my value is 470k, and this value is 1k. So I will double click and change the value 1k. Click OK after this. Okay, so done with the schematic. So I will go to save this desktop circuits, then CIR23. Okay, now I can have not PCB preview is not available for diode D1 and D2. So if I click on arrays, it will show you it will show me a direct warning message like this. Okay, no D1 and D2 are available, so no packages are available for D1 and D2. So you can have cross marks, no, not packaged. Okay, so here we'll get a cross mark. So how we can have a packaging of this? So I will close this again. So for the packaging, so right click on that device, go to packaging tool. So there it is available, packaging tool. So I will show you here. Once I right click, go to a packaging tool. Okay, click OK after this. we need to add the package for this. So click on add the package we require as a LED package. So we'll select the LED package. So LED is available, so package is available, so you can look at this PCB preview as well. So click OK after this. So OK is available here. Okay, click OK after this. Okay, then we need to assign the package. How to assign the package? So for A, we need to assign as A. So click there. B, assign the B. Okay, we have done the assignment. So click on assign package. It will show you warning message. Click OK, and you can have a user device package. So we'll select user device and save this particular package. Update this particular thing. Yes. So once it's updated, so you'll get A and K symbol here. Also A and K symbol for the diode D2. So again, save this particular thing. Now you can click on this particular layer. So we can observe now the package is available. So select on a component mode, D1, the packages are available. Okay. All right, now how we can do auto routing? So for that, again, very first thing is select this 2D graphics mode, select a board edge, draw one particular board. Okay, so board has been drawn. Now select the components. You can place the components anyway how you want to be placed. Anywhere you can place. So I require 2 LEDs on the top side, so I'll keep 2 LEDs on the same side. Jumper, I'm going to connect it here. R1, I'm going to put rotating. So 1 and R2. Okay, done with this. Okay, so I have drawn a 2 big size board, so I can select the board again. I will reduce the size of the board. Okay, you can press near and outer side of the board as well. So this is done. Okay, now very first thing for the IC based simulation is we need to assign the IC padding. So how to assign the IC padding? Go to this, here it is DIL IC pad. Okay, so we can have standard DIL pad. So this is standard DIL pad, this is mini DIL pad, SMD DIL pad. So we can have a standard DIL pad. Select the pad, rotate the pad and place it here. Standard DIL pads 1, 2, tool set. So if it shows like this red mark, so there might be some error. So we need to remove that. Delete it. Rotate, press it. Okay, this error because of wires and all, so we'll keep as it is, that thing. Here. Okay, so done with this now. Now we need to auto route this particular thing. So we have done with the placement of this thing. How we can do auto route? For that, again, go to a track mode. Right click on a default, edit it. So instead of 30 th, we'll keep 20 th. Okay, save this particular thing. Now for auto routing, go to tools. There is auto router available. So click on auto router. So before beginning with auto router, we need to define the rules. So how to define the rules? For that, go to design rule manager. Here it is, design rule manager available, or we can go to go to technology and then design rule manager. Okay, net classes, net. So for the signal, we need to select bottom copper, and this has a bottom copper. Click OK. Again, go to design rule manager. Net classes for the signal, both are the bottom coppers. We have done. Vertical and horizontal lines are both bottom coppers. And then go to auto router. So here it is, auto router symbol available. So we'll start begin routing. So here it is wire grid and wire grid. So once you start begin routing, it will automatically generate the routings. So it will do multiple iterations. So there are 14 nets missing, 3 net missing. So here we'll go, 3 nets are missing, 19 DRC checks. So 19 DRC check we'll get here. So we can observe the DRCs available. So why it is showing the errors? Because this net is not connected somewhere else. These nets are not connected somewhere else. So like this, these are having error. So these 3 nets are not connected. 3 nets are missing. So you can click on that. We'll get the points where the source and destination of this particular thing as well. Okay. So the auto routing has been done. So we can go to a 3D visualization and look at the PCB. So we'll place the components and check. So this is the layouting, and this is the way. Okay, we can have the PCBs. Okay, all right. So we can put the box on this. So which are the components are coming out from the box and all. So those things are available here directly. Okay. Remove the box, remove the components. You can rotate like this. You can flip the board. Okay. So you can zoom in, zoom out. Okay. So again, we can export this particular thing via this. Go to PCB layout, click on output, then export graphics. We can have an export bitmap as well. So we can export this automatically. Click on export, and then the export has been done. Okay. So this is about the automatic auto routing of the PCB. So I'm going to save this particular thing. All right. Okay. Close this. Okay, so demonstration has been done of the PCB, how we can route the PCB and all. Now we'll see how we can create a homemade PCB. So homemade PCB, that is a single layer is possible. So very first thing is create a layout. Take the print using the LaserJet printer. Mirror image again. I have shown you how you can export this thing. Take the copper clad, scrub it, remove the corrosion of the copper clad, clean it. Then put the printout paper on the copper clad by keeping one cotton on that, and then press the iron on it. Okay, due to heat, the ink on the paper will be pressed over the copper clad. Okay, because of the heat tracks appears on the copper clad, like tracks will appear on the copper clad. Now highlight the traces by using marker pen. So take the black color marker pen and highlight all the traces. Now you can put that your PCB onto a FeCl3 solution, that is ferric chloride solution, for etching. So this process is known as an etching. And then drill using a hand drill or auto drill. So we'll have a hand drill, small hand drill is available, so you can drill it using hand drill, or you can use auto drill for drilling it. Then place the components on the PCB and test it. So this is a very simple process of homemade PCB, how we can prepare a homemade PCB and all. Okay, so now I have shared a feedback link and quiz link available in the chat window, chat box. So open the chat box and give me a feedback. Also, the certificate link is available in that feedback link as well. So just click over that, give the feedback. You will get the certificate on your registered mail ID. Those who are not subscribed my channel, please subscribe it and press the bell notification bell icon for next upcoming updates. You can contact me on my mail ID, Niraj B Kapase @pkts.com, or my personal mail ID is nirajkapase@gmail.com. So you can contact me on that as well. So feedback link and the quiz link is available. So you can click on that feedback link and a quiz link on the chat box. So open the chat box and click on those particular link. You'll get certificate will be generated automatically through that link. So type your email ID properly, type your name properly, because it's going to import the data from there. Okay, so thank you for listening patiently. So I'll keep this open for another next 2 hours. So this links is open for 2 hours, so you can give the feedback and you can get a certificate within these 2 hours. Okay, next 2 hours. All right. Okay, thank you. My contact details are Niraj B Kapase at gmail.com, Niraj B Kapase at dkds.com, Niraj Kapase at gmail.com, Niraj B Kapase at dkds.com. Thank you for listening me patiently. Thank you.